But I can promise that I will fulfill the expectations, and I will be the scary chairman, keeping the time, including my own time, what will be probably the hardest challenge in this session. So I'm really glad to see you all from all parts of the world, and also to see that how diverse and colorful and wonderful the Linz team also who organized this conference. So thank you, Zsolt, and thank you, Eva, Martin, and all those who put together this fantastic, diverse program for us in the topic of designing innovations in STEAM education. And this session is really a moment when the dreams come true, at least for me. So my name is Kristof Fenyvesi. I'm working in the Finnish Institute for Educational Research in Central Finland, and I was really lucky to met and know, and I can maybe dare to say that I'm friends with all the speakers of this global session. So we will have speaker from Africa, from North America, and also from Europe in this session. And all of them are my really close friends. I met with them on various points around the globe. And it's my great pleasure to introduce you them. When I heard about the theme of the conference, and then I saw that there will be design on topic today and these 3 days, then I thought that though in educational research context, design also have very specific meanings. So 21st century is definitely centuries for design, when we have a lot of meanings for this term design. But I didn't want to miss this opportunity to invite those designers and design educators who really have to do and close relationship with the core of this term, what design mean for us modern people. So they will be the ones, I think, who also open up these connections, and also those who help us to understand that how design education looks like today, and how it can be connected also to STEAM and all these multidisciplinary, transdisciplinary connections of these topics, what you all have today. But who are the speakers? So first of all, we will have Suné Stassen, who is from Cape Town, from South Africa, and she's the CEO of Open Design Africa, which is not only an event, but a real movement. I can tell you, I was happy to visit her event in Cape Town, and I could see that it's a very intense and a very rich event in every sense, and it really represents the community aspects, the community of basis of design, and really a future thinking event. And she's also the one who been key person to contribute to the South African education of design as a subject. In the secondary school level, she contributed to textbooks and editing a lot of materials, and also currently Suné is one of the global ambassadors of the open design idea worldwide in various events like UNESCO and World Design Capital events all over the world. So she will open our session, and I'm really looking forward to her talk. After her, we will have Brady Peters, who is an assistant professor in the University of Toronto, and he's also a founder of a movement called Smart Geometry. And this is also an event in the same time, but they have activities all over the year. And this is also a pool of highly creative people coming from different fields of innovation and design and research. And he has an extensive background, not only as a theoretician, but also as a practitioner and an architect. He worked with the top architecture offices around the world. And Brady has really insight to many layers of what design and design education and also computational thinking have to do with contemporary design, also as an art and also as an aesthetic movement. And last but not least, or how can I say it, I never remember this anyway, we will have Zsolt Lavicza, whom I don't need to introduce, at least not in this context, because he had also a very extensive career, started from Hungary and all over Michigan, US, and Cambridge University. And now he's enriching the STEAM portfolio of Johannes Kepler University in Linz with his huge army and peaceful army of researchers from all over the world in this fantastic doctoral school. So I think there will be also a great dialogue in the end of this session. So now I would like to give the floor to Suné Stassen. Suné, please open our session and make your talk.
Thank you very much, Kristof. Just bear with me. Let me just get this show on the road.
Yes, now we see your slides.
Great. Good afternoon, morning, and evening to everyone that's joining us. This is really a great invitation, and I love being here, and I'm very excited to be here and also to learn more from my fellow panelists later. And I sincerely hope that I will manage to deliver a few takeaways for everyone today. So let's jump right in. Warm greetings from beautiful Cape Town, South Africa. I am Suné Stassen, a designer, educator, impact entrepreneur, and the founder and CEO of Open Design Africa. I always look at our man-made world through a design lens, with the human race at the helm as the chief designer. For generations, we have successfully engineered a destructive and unjust world for living in. At Open Design Africa, we believe that collaborative, creative intelligence is a superpower. We also believe that every child and citizen should have the right to develop it. This will enable and empower everyone to confidently contribute to the future making of a world we can all feel proud to live, work, and play in.
Open Design Africa calls on
all Africans
and people from around the world to action small seeds of change.
everywhere!
Because collectively,
The impact will be massive!
Today, we have the most important design brief to write in the history of mankind to secure a thriving future for humanity and the planet. Our African humanist philosophy of Ubuntu beautifully defines that I am, you are, because of who we all are. Let's design our futures together. Okay, the current global pandemic, I think, sharply heightened our awareness of thriving inequalities and how everything in this world is connected, which in my opinion simply puts a crucial spotlight on the fact that every citizen of this world, no matter their age, is a vital contributor to the creation of our world. But do we prepare them and empower them with the correct skill set to enable them to fulfill this important role? So let's quickly explore the design challenge at hand and see if we can identify the core building blocks needed for this crucial design process that should, at the end of the day, enable and empower humanity to thrive and design the future world we desire today. While watching, consider what skills we need to develop in children to transform society and our environments in the future.
Fun fact, planet Earth is 4.5 billion years old. Mankind, about 140,000 years old. Let me put that in perspective. If you condense the Earth's lifespan into 24 hours, that's one full day, then we have been here on this planet for, drum roll please, 3 seconds. 3 seconds. And look what we've done. We have modestly named ourselves Homo sapiens, meaning wise man. But is man really so wise? Smart, yes, and it's good to be smart, but not too smart for your own good. Yes, we have split the atom. Yes, we build clever machines that navigate the universe in search of new homes, but at the same time, those atoms we split created nuclear warfare. In our quest to explore the galaxy, rejects and neglects the home that we have here now, so no, that cannot be wisdom. Wisdom is different. While intelligence speaks, wisdom listens, and we willingly covered our ears to Mother Nature's screams and closed our eyes to all of her help-wanted signs. Wisdom knows that every action has an equal and opposite reaction, so if we were wise, we would not be shocked when we see storms that are stronger than ever before, or more drought, hurricanes, and wildfire than ever before, because there's more pollution than ever before, more carbon, more trees cut down than ever before. At a record pace, we have increased the extinction of animals by 1,000 times the normal rate. What a feat. In the next 10 to 100 years, every beloved animal character in every children's book is predicted to go extinct. Lions gone, rhinos gone, tiger, gorilla, elephant, polar bear gone. In 3 seconds. Species that have been here longer than us will be gone because of us. In this 3 seconds. In an existence shorter than a Vine video, we turn the circle of life into our own personal conveyor belt. Somebody, anybody help. We were given so much, the only planet in this solar system with life. I mean, we are 1 in a million. No, actually, scientifically, we are 1 in a billion, trillion. That's a 1 followed by 33 zeros. And I don't want to get too spiritual, but how are we not a miracle? We are perfectly positioned to the sun so we don't burn, but not too distant so we don't turn to ice. Goldilocks said it best, we are just right. This paradise where we are given medicine from trees, not coincidentally, but because like the song says, we are family. Literally, everything, every species is connected genetically, from the sunflower to the sunfish. And this is what we must recognize before it's too late, because the real crisis is not global warming, environmental destruction, or animal agriculture. It is us. These problems are symptoms of us, byproducts of us. Our inner reflection, loss of connection has created this misdirection. We have forgotten that everything contributes to the perfection of Mother Nature. Corporations keep us unaware and disconnected, but they have underestimated our strength. Contrary to popular belief, millions are waking up out of their sleep, seeing our home being taken right up under our feet. We cannot allow our history to be written by the wicked, greedy, and loony. It is our duty to protect Mother Nature from those who refuse to see her beauty. Call me crazy, but I believe we should have the right to eat food that's safe, with ingredients we can pronounce. Drink water that is clean, marvel at trees, breathe air free of toxins. These are natural rights, not things that can be bargained for in Congress. See, they want you to feel powerless, but it has been said that something as small as the flutter of a butterfly's wing can cause a typhoon halfway around the world. But when enough people come together, we too will make waves and wash the world into a new era filled with love and connection, freedom for all without oppression. But it is up to you, yes, you watching this behind this screen, to make the effort, because time is of the essence, and only together can we make it to the 4th second.
So my takeaway is that the triple bottom line forms the foundation of this design process. And instead, we have disregarded 2 of the core pillars. For generations, we have literally executed a silo approach, which resulted in a complete disconnect across all levels of society and business, government, and in our environments. This not only had, of course, a devastating ripple effect felt by generations, but at best, I think the legacy of the human race has been one of destruction and a world that is constantly in survival mode. Humanity's inability to systemically approach the design of our man-made world have physically and mentally captured and disabled global populations from prospering and confidently contributing as contributing future makers. So my question to you is, what shortfalls, especially with regards to skills development and education, can you already identify? And what's really missing that can help to turn things around? Yes, today we do have the most important design brief to write in the history of mankind. And we have to start thinking about a design brief that should invest in developing a thriving future for humanity and the planet. To follow are just a few observations and core building blocks that should strongly inform our approach towards skills development, education, and the design of a thriving future across the triple bottom line. I think as an intelligent species, I strongly believe that we are equally capable of designing the exact opposite, but only if change is driven through wisdom instead. Now, as the top designer of ecologies, nature really boasts with the most impressive portfolio of successful models and processes and systems that stretches across 3.8 billion years. And I think it will be very wise to learn from nature and implement these learnings across education and across all other sectors. Why do we continue to reinvent the wheel with solutions that's less impactful and sustainable is what I want to know. We have to learn how to approach our man-made world as a holistic design challenge and aim to develop strategies that can thrive for 10,000 generations or more, the same way nature does. And I believe this is the greatest legacy worth aspiring to. The United Nations Sustainable Development Goals, of course, have fast become the world's global compass for large-scale transformation. And it helps us to really cut through the noise and clearly identifies priorities within diverse sectors. But this also helps us to identify future-making skills that people need across the board in order to add significant impact and value so that we can collectively work towards achieving and upholding the United Nations SDGs. Now, although the fourth industrial revolution creates, of course, a lot of anxiety for many, and understandably so, it also suggests unique and exciting opportunities to affect large-scale transformation that's crucial to achieve and uphold the UN SDGs. But in order to do so, a symbiotic relationship between man and machine will be vital in order to succeed in the future. Priority investment in technology and tech skills without equal investment in creative intelligence, in my opinion, is not driving and serving this agenda. This includes future-making skills like empathy, imagination, creativity, emotional intelligence, critical thinking, complex problem solving, even persuasion and collaboration, just to mention a few. But that really defines and differentiates us from the machine. It's our only competitive advantage. And the reality is that any other investment will eventually prove to be short-lived without equal investment in the development of appropriate social and human capital that can drive future prosperity. And I think history has really proven that no one pillar can succeed in isolation, and innovation should always be guided by humanity and creative intelligence, because this will secure the development and implementation of appropriate strategies and the creation of products and environments and systems and services and related tech that have relevant impact, because it has significance and real value at the center of its creation and future application.
Among all the challenges, I think the most challenging thing is about education. Even if today the best university of the world will face the same challenges, because everything we teach our kids are the things that in the past 200 years, the things we taught them the machine will do better. So we have to think about what is the best way, what are the contents to teach our kids in the future. We have to teach the kids that win the machines, the machine will never be able to win the man. This is my belief, because machine only have the chips, human have the heart. So I think we have to change from now on the education system. In the future, it's not about the competition of knowledge, it's the competition of creativity. It's a competition of imagination. It's a competition of learning. It's a competition of independent thinking. If you think like a machine, the problem will come. In the past 20 years, we make people like a machine. In the next 20 years, machine will look like a people. So in the future, it's not knowledge-driven, it's the wisdom-driven. It's the experience-driven. So in the past, it's the knowledge-driven, and it's the manufacturing-driven, and in the future is the creativity-driven. So this is what we think the world should be focusing on.
So we all can agree that education shapes the fabric of society, and I think to date we have to admit it has been a significant contributor to inequalities across generations. Besides the fact that we all know that we learn in different ways, the education we have experienced across generations did not optimize participation and opportunity for all children to develop their full potential. It certainly did not enable society with future-making life skills. And now this is the magic of creative experiences through phenomenon-based learning, play, and STEAM education. It truly democratized participation and optimize the learning experience and the development of crucial future-making skills in all children and across all levels of society. And this, I hope, is an important takeaway for today. Let's do a quick exercise and make it a little bit more personal. You're welcome to also share your thoughts in the chat box. To the parents and educators joining us today, which people skills or human qualities do you want your child or learners to develop so that they can truly thrive in the future? And what qualities are you looking for in people to employ or collaborate with that you believe will add real value and significance and meaning to either your business or a project? And lastly, which human qualities do you believe defines a great leader that will also stand them in good stead as a future-making leader? Now, not too long ago, Forbes made a profound statement that creativity is the top leadership skill of the future. And I think this acknowledged that the role and impact of creativity stretches way beyond the creative economy. You see, leaders and with creative intelligence are thought leaders and future makers who, for instance, know how to apply their knowledge, experience, and emotional intelligence and empathy in order to drive productivity of appropriate innovations that can deliver desirable and meaningful results. They will definitely make a crucial contribution towards helping us achieve future urban ecologies that reflects regenerative economies, flourishing environments, and thriving communities. Something interesting data were collected by LinkedIn from about 600 million plus professionals and 20 million jobs. And they all concur that the following skills are already in high demand. Now, creative and playful experiences will optimize the development of these skills in all children and in civil society. I think that's something we need to take note of, the role of creativity. Albert Einstein once said, imagination is more important than knowledge, and I could not agree more. Time for us to start imagining a transformed society. What will the future look like, where every citizen is, for instance, empowered with creative intelligence and enabled to fully participate and contribute as future makers? What building blocks should this design process include that will enable humankind to leave a legacy for 10,000 generations and more? Now, just imagine the immense added value and the ripple effect on our future economies, environments, and communities if emotional intelligence and empathy, for example, guided every decision we make today. Might it be in government, as leaders in business, or even in our personal lives and in our communities? This is why we at Open Design Africa believe that collaborative, creative intelligence is a superpower, and that every child and citizen should have the right to develop it, so that we can collectively and confidently contribute to the make of a future world we can all feel proud to live, work, and play in. Since the future of humanity and our planet depends on it, are you ready to collectively fight for creativity in education with the same urgency we are fighting for climate change today? Let's start embracing the power of creativity everywhere, because collectively, I do believe our impact will be massive. It's time to really start designing the future together. Thank you for your attention. I am excited to discuss more later, and over to you, Kristof.
Thank you very much, Suné. We already got several comments, so people were definitely impressed, and you made us thinking. I think this is what we needed also in this conference, this broad vision and this depth of the content. So thank you very much for the eye-opening talk. So we are moving on in the session towards Brady Peters. I already introduced Brady, but for those who missed the beginning, so Brady is a design educator and designer and architect from the University of Toronto, with a wide, extensive career also in practice of design and theory of design and implementation of design in connection with computational thinking, with modeling. So all those aspects which are also discussed in the conference. And I need to mention, I think in this context, that I first met with him in the Newton Institute in Cambridge. So in the circle of mathematicians and scientists who wished to think beyond maths and science. And that was the reason why Brady was also the guest of Newton Institute. So the floor is yours, Brady. We are looking forward to your talk.
Okay, thank you very much, Kristof. And thank you to Suné for a fantastic presentation that preceded mine. I think my presentation is going to be totally different, totally change gears here. Let me just share my screen. Okay.
Yes, we see your presentation.
Okay. We can see the presentation now, Kristof?
Yeah, absolutely. Thanks.
Perfect. Okay. So I've titled my talk today, Creating Knowledge Through Collaborative Designing and Building. And this is where I work normally during non-pandemic times. This is the John H. Daniels Faculty of Architecture, Landscape, and Design. Our faculty also includes visual study, and recently forestry has also joined us. We moved into this building recently in 2017. It was originally built in 1875 as the home of Knox College. You can see the large addition in the back of the building. And this is where I have my lab. So this is the robotic prototyping lab. My research that I do right now myself sits at the intersection of sound and architecture. And I really began this line of inquiry when I was doing my PhD, which was done in Copenhagen, Denmark, the Center for Information Technology and Architecture. But before that, before University of Toronto, before Copenhagen, I worked as an architect for this architecture firm, Foster & Partners. And I worked in architectural practice for about 8 years in London, the United Kingdom. And I was part of the research and development group at this office. And I worked on a huge range of projects with a huge number of really talented people. I was fortunate that some of my projects actually got built. This is the Kogod Courtyard in Washington, D.C. This is the 51 Lime Street Tower and the Thomas Deacon Academy in Peterborough. And as mentioned previously, I'm also director of Smart Geometry, along with several other directors. This is us. But I've been involved with Smart Geometry since its very beginnings, and I was made director in 2013. I also wrote the book on Smart Geometry. So my wife and I published this book on Wiley, sort of in honor of the first 10 years of the group. So what I wanted to talk about today a little bit is what is Smart Geometry?
Smart Geometry is a 6-day event that's happened approximately once every year. The event consists of a 4-day workshop and a 2-day conference. The 4-day workshop, which precedes the conference, participants are organized into 10 different cluster groups, which each are led by a group of cluster champions that investigates a particular research question. At the end of the 4 days of workshops, the clusters will basically produce some sort of an object or series of drawings or set of visualizations. Something that's a little bit new this year is we're really trying to incorporate other disciplines into that conversation. And so we've got crystallographers here, we've got psychologists, and we've got roboticists, and we've got people who are interested in artificial intelligence, alongside structural engineers and computer scientists, as well as architects of a whole load of different flavors. In most other conferences, people do research and then they bring it to the conference to share it with other people. But at Smart Geometry, the idea is that groups of people who are very skilled at what they do can come together to have a conversation about a series of research topics and actually develop new knowledge through doing experiments as part of the workshop. In that way, new knowledge is actually created at Smart Geometry. And this, I think, is sort of the fundamental difference that what sets Smart Geometry apart from other architecture conferences.
So that briefly explains what Smart Geometry is, but I think we have to take a step back and think about why Smart Geometry. Why did Smart Geometry come about? And for this, I think what we need to do is take a look a little bit into the recent history of architectural design technology. So I will contend that architecture equals drawing. The definition of what it means to be an architect is very much linked to our design tools. As Jonathan Hill has pointed out, it was the invention of drawing that enabled the creation of the architect. The architect is defined by our ability to draw, and through drawing, conceive of and communicate plans for building at a remove, both spatially and temporally, from the construction site. And it's been this way for more than 1,000 years. But the thing is, design technology has changed. And so I would argue that it's no small matter that the design tools which define us as architects have also changed. In 1963, Ivan Sutherland introduced the world to the first CAD system, Sketchpad. It could draw, it had parametric capabilities, it could do simulations and calculate structural performance, and link geometric designs to numeric databases. Sutherland recognized that the computer offers considerable potentials that are different and greater from the drafting board. using computation was not just another way to draw, but a new way of thinking. However, when the first CAD software for architects was released, AutoCAD, it was essentially a 2D digital design drafting tool. As Robert Aish writes, in retrospect, 2D drafting is really a travesty of Sutherland's original intentions. The spectacular flaw of 2D drafting is that it failed to harness the potential of the computer as a creative design tool. So while there were some parametric computational drawing programs, there were few or none available to architects, and this frustrated some designers, and a few went out and did something about it. Smart Geometry was founded in 2001 as an informal network of designers interested in harnessing the powers of computation for architectural design. Friends and former colleagues Lars Hesselgren from Cohn Peterson Fox, Jay Parrish from Arab Sport, and Hugh Whitehead from Foster & Partners felt frustrated by the lack of resources and professional network surrounding computation in architecture and sought to redefine the way architects could use digital tools. And it was in 2001 that I moved to London to begin my professional career as an architect, never expecting at the time to become so deeply involved in the development of design tools in architectural computation. My first job was in structural engineering firm Bureau Happold as a physical model maker in the London office. When I was at university, there was no digital design. I only started doing CAD in my last year of my degree, and model making was my primary mode of investigation. And so this is what I was hired to do at Bureau Happold. And there as well, I did many drawings of different types to help my model making and communicate concepts to architects and clients. Computer models for me were at first just a way to make better physical models, but also a good way to communicate. I skipped right past the two-dimensional CAD. Modeling in 3D was just like modeling in the real world. 3D modeling was faster, and many drawings could be taken from the 3D model. The digital model could be modified easier than physical models. This is the design that I worked on for a house by Yoshida Finley Architects, a digital model provided for the engineers by the architect to design a structural system. I sliced this up using CAD, made a series of sections out of it, making a coherent structure where there was none previously. However, iteration was challenging. I mean, the geometry here was challenging too, but it was really the iteration. How can we change this design? How can we use computers to better explore the design space? So I asked myself, there must be a better way. How could I express design in terms of geometric relationships? I knew there must be a better way than just remodeling this every time. And it was at the first Smart Geometry conference in Cambridge, UK in 2003 that I had the opportunity to see Hugh Whitehead speak. And he explained how he was using something called parametric design to design the new Swiss Re office tower in London. I knew that this was the answer I was looking for, or at least part of the answer I was looking for. This made sense to me as a designer and a model maker. As an architect, I always think in terms of geometric relationships anyways. And here was Hugh describing the system for creating these associative systems and using them to explore design space and create these amazing buildings. I had to know more. So I left Bureau Happold and joined Hugh Whitehead and his team at Foster & Partners. So the first project I worked on there was this project called the Great Canopy, West Kowloon. The project was a second stage design competition, and there was a whole load of people working on different aspects of the project: residential towers, transport system, parks, offices, retail, etc. But I was pretty much solely responsible for this 1.5 kilometer long roof structure. And so, as I had hoped, I learned about parametric design. And parametric design, as we implemented in this project, worked well for design exploration and for the careful definition of complex surfaces and the creation of these geometric relationships. But the problem was, how do we scale up? It was good for creating these geometries, but how do we scale up? We were looking at space frame structures for this roof surface. But how was I going to generate the hundreds of thousands of components for this structure and generate this within a reasonable amount of time? And so this is where I learned how to computer program. And so in 2008, this was the state of design computation in architecture. So I would say that there was two basic focus areas: the development of associative modeling tools, such as generative components in Grasshopper, and new approaches to computer programming, to scripting and CAD to generate geometry. So in the early years of smart geometry, the group really focused on software. At first, the founders of smart geometry, Lars, Hugh, and Jay, drew on their network of friends and collaborators, such as computer scientist Robert Aish, academics Robert Woodbury and Axel Killian, and practitioners such as architect Mark Burry and engineer Chris Williams, to put together a few modest conferences and workshops. The early smart geometry workshops provided inspiration and a testing ground for the creation of new parametric software, generative components, that was introduced to the group by Robert Aish, who was the chief scientist for Bentley Systems. Aish's software came out of not only the ideas of Hesselgren, Parrish, and Whitehead, but from a legacy of computational thinkers, including Ivan Sutherland and Christopher Alexander, who was using formal graph methods as a descriptive technique to help designers understand the structure of resulting products and systems. So smart geometry, particularly in these early years, was very much about the development and testing of new parametric tools for architecture. The smart geometry directors pushed for design tools that were free from restrictions and would enable a higher level discussion of building form in terms of first principles. And this led to a discussion of geometry and mathematics. As a more generic approach, thinking of architecture and form in this way allowed them to share computational tools between disciplines. And what we were finding in architectural practice, but also at the smart geometry events, was that this technique, the parametric model, combined with computational scripts, allowed for much easier collaboration, communication, and exchange of data between disciplines, between architecture and engineering and other consultants, and it could help to link the conceptual, programmatic, and performative aspects of a building. For various reasons, generative components would not ultimately be successful. However, another parametric software, Grasshopper, developed by David Rutten in 2007, would eventually become ubiquitous in architecture schools and leading architecture practices around the world, and indeed in smart geometry. And one of the reasons for this was the ease in which developers could create plugins for Grasshopper to extend it. And now we can find a whole ecosystem of software that integrates a wide range of building design and building science aspects within one computational system. So the first phase of smart geometry was focused on software development. And by 2009, architecture now had a widely available parametric software that could be used within our architectural design environment. However, smart geometry had also created a community of like-minded people and redefined the way architects could use digital tools, and not just architects, but engineers, artists, computer scientists, etc. So in 2010, we decided it was time to try something new. We made a shift away from a software focus and moved to a focus on fabrication, but not just only fabrication, but a linking of the design environment to other ways too, to simulation, to visualization, to sensors, to actuators, etc. And so we tried this new smart geometry format first in 2010 in Barcelona, and this is the format that smart geometry remains today. The event now spans 6 days with a 4-day curated workshop, a 2-day public conference that attracts more than 300 international participants every year. I'm not going to be able to go through all of the amazing work that has been done at smart geometry over the years, but I would like to highlight this event, the 2016 event at Chalmers in Gothenburg, Sweden. Ideally, when we run a smart geometry workshop, we want to use a space like this one, a huge industrial space with room for all of the workshop clusters and their associated computation and fabrication machines to work together. The conference itself is perhaps the most standard part of the event, not as special as unique as the workshop, but this is where we have keynotes interspersed with presentations from the workshop groups. And finally, there's the exhibition where the workshop and conference attendees can see the work of the cluster groups, a place for inspiration and conversation and perhaps a glass of wine. So I'm going to take you through just a few few of the clusters that were at 2016 to just explain a little bit the range of projects that were done. The 20,000 blocks above the ground cluster paired architecture with games design and robotics and asked, can gameplay be used to guide non-expert groups in creating architecture, which basically amounted to customizing the popular Minecraft game to output instructions to fabrication robots. The Logjam cluster combines structural engineering tools with design optimization techniques to explore the potential of wood interspecies optimization for the construction of spatial structures. The Nanogyroids cluster brought together the fields of crystallography and architecture and mathematics and investigated how gyroid-like formations, along with other ways of interpreting structures and materials at an atomic level, with the aim of exploring how these three-dimensional surfaces can have a transformative potential in the design of objects and spaces surrounding humans. The Mars cluster researched the challenges and opportunities of using an autonomous swarm robotic system construct a protective shell for a Martian habitat. The Atmospheric Delight cluster aimed to produce generative feedback loops between spatial scenarios and user experience through close working relationship between architecture and cognitive science. The Sensory Detectives cluster designed an immersive design experience that both visualized and physically simulated a thermal environment and questioned the dynamics of heat, moisture, and air within an atmospheric pavilion. They designed modular architectural elements and that inhabitants could experience and affect through their body, electronic sensors, and augmented reality. So, what lessons can we learn from smart geometry? So I've tried to distill perhaps some of the lessons that I've learned over the many years I've been involved with the group. So number one is to provide the platform. Smart geometry provides the venue, the funding, and structure for the co-creation of knowledge. That is, knowledge is created at the event. So instead of coming to an event and presenting pre-existing finding, the workshop model requires new research and new findings to emerge through collaboration. The second point is people, finding the right people. Smart geometry purposely mixes people from professional practice, from cutting-edge research, and enthusiastic students. Smart geometry actively encourages and indeed sometimes requires interdisciplinary collaboration. And finally, smart geometry is non-hierarchical and selects talented participants from all career stages. And the third takeaway is process. The goal of the Smart Geometry event is not the publication of papers or proceedings, though papers are certainly written. And while objects are produced for the exhibition, the primary goal is the development of new ways of working and thinking, new processes. Emphasis is always placed on action, on doing and creating at the event. So these would be my three takeaways: platform, people, and process. Thank you very much.
Thank you. Thank you very much, Brady. I think we just heard about and saw about the so-called other sides of the coin here. And there were many connection points with Suné's talk. So I really can't wait Zsolt's contribution to the session, and I think we will have everything set for a great conversation, especially if we will have some time in the end of the session. So Zsolt, the floor is yours.
So thank you very much, and really impressive presentations. And I think my presentation is just 5 minutes of what we are doing here, but I think I'm complementing it, both of your presentation from an educational perspective. So both for reaching out and then and contributing to the world, and then also software development, maker culture, and then so on. So what we are doing here in the Linz School of Education, that we are doing STEAM education research. We are approaching research from many different perspectives. And at the same time, 10 meters from us, there is the GeoGebra development team who is designing software for education. And it's an open source project. I think many people know this. So we have more than 100 million students and teachers are using it all over the world. And since this is an open source project, the community is contributing to the educational view. So yesterday and then today we already had amazing applications. So we are designing software and the community is designing many pedagogies. And then also we have a cool lab which is computational thinking and thinking in the direction of the future. That's how we can develop robotics and the computational skills. So what we are doing is in way software development and then also pedagogy development, and we're also trying to contribute to policy. So our focus is really on creativity and innovation from an educational point of view. So we are creating software for education and then for the community to be able to produce all of this environment. So now, for example, we just released the GeoGebra Classroom, when groups can work together, teachers can create virtual classrooms and so on. We are creating a gamification platform that it would be a possibility for every teacher and students to create a gamified environment. But we are going to 3D printing and augmented reality. So the software includes this, and then we are building different kind of pedagogies on this. So my PhD student here, Imam, sitting here working on micro games. Some students are working on different games and flip classroom environments, and then we are trying to create it in a different format, and then we are experimenting with this. So one of the approaches is then that we try to connect the physical and the digital world. So we have lots of different projects and PhDs working on that, how we can create a new kind of manipulatives, which is digital and physical. And then since the kids are moving between the physical and digital environment seamlessly, then we try to connect this with different kind of materials. And then we use lots of 3D printing and augmented reality and all possible manipulatives. So these are some of the examples. And then we are also engaged a lot with game design. And not only we are designing games, but the students are designing different kind of games in the schools. And then we have huge competitions with simple examples to create these games and then integrate it into classroom environment, and then move forward with this creativity and education. And then we use a lot of architecture. So yesterday we had really amazing presentations about our architecture project. So Shireen, my PhD student, is looking at how to explore Egyptian architecture, how to use augmented reality, 3D printing, scanning, and then modeling of different kind of architectures in the. So my other colleague and student in Korea is looking at Korean architecture. We are looking at outdoor mathematics. Ben in Luxembourg is looking at Mad City maps. So students create trails in their cities to explore architecture in their cities, and then use augmented reality modeling. They print it out. And then also we had a big project in Israel to integrate in this the cultural environment, and then also the architecture and the arts in modeling for education. So there are lots of different places where we are going to have this kind of modeling and design. And also we try to look at the culture of the students. So our PhD student just got her PhD on Monday, looking at internet memes, and then she's running an internet meme, mathematical meme sites to use mathematical memes for teaching students. My other student in Iceland is working on short videos. So students are becoming YouTubers in the classroom to create short videos and then narrate each other's videos, and that this create opportunities. We work a lot with origami, and then also Yuka in Finland, looking at the well-being of students, that how we can create environments for students to in the classroom to explore mathematics and STEAM approaches, or we use the donut models for sustainable development, and then we are creating doing different activities. We use real-world data to in the classroom to model things all over the world. And we have lots of different projects, all based on STEAM. So in the past year, we got 9 Erasmus projects, and then many more to come to explore STEAM education, arts, mathematics, design, creativity, and all of this from a different perspective, and then try to integrate both in teacher education, in universities, schools, from the students' perspective, integrating artists, teachers, designers, architects in these different projects. But it would be another long lecture. And then we also try to facilitate all of these activities here. So we organize lots of conferences. So I think this is our 15th conference, or we didn't count. I think we should we should count, and then in different topics. So we just had the mathematics in the digital age. We have the young researchers conference in March, and then also we are organizing the European young researcher networks. And then what Brady just showed, that we are collaborating with the Ars Electronica Festival, which is a very similar topic. And I think Suné, you have a similar festival in South Africa. So we have more than 100,000 visitors here. So tomorrow morning, the director of the Ars Electronica Center is working. And Linz is really the kind of media city of and also a kind of design city. So we have new projects, new spaces opening up. So we could facilitate many of these events and then collaborate with all of this. And then I have a great team of more than 40 PhD students and postdocs, and we have lots of visitors all the time. And then we just moved to a new building. I think I cannot, I need to turn off the background, but I could show you that we have a really nice building. And then we are opening a STEAM lab, and then we are very happy to collaborate with everyone. And then hopefully next time we will be able to meet you here, and then maybe you could visit us or develop in these connections. So I think then that's what I wanted to say very briefly. And then if you are interested in the details, my students are presenting in the parallel sessions, and then we had really great workshops yesterday. So thank you very much, and then hope we will continue from here.
Thank you very much, Zsolt. It was really mind-blowing presentation of the context, just to know where we are. And I know that Linz was the European capital of culture maybe a decade ago, but now we should call it as the European capital of STEAM. Thanks to your team and your contributions. And to open our little round table, I would like to make this virtual table big enough for everyone to sit with us. There are no seating problems this time, fortunately. So you are welcome to make your questions and contributions to the discussion on any points. just to open the discussion and make some time for you to collect your thoughts, I would like to reflect a little bit together with the participants of the session to the current situation. So, of course, we are in the midst of a huge crisis, especially and mainly now COVID-19 crisis, and in critical situation, all the senses in a good sense start to work more sharply, and we start to identify gaps and also opportunities probably more clearly. So I would like to ask you that what kind of difficulties and gaps you had identified in this critical period in the context of STEAM education, design education, and also what kind of opportunities emerged just in your context and in the context what you have presented to us. So what you have seen the main challenges, what opportunities opened up for your projects, for your initiations, what were your clearest vision in terms of good and bad in this critical situation. So first, Suné, please.
So is that how we're going to roll? Number one, number two, number three. Last year, Open Design Africa is we always positioned the organization as a collaborative public platform. And inclusivity and accessibility is one of our main things, because we believe if we want to create the kind of change that this world needs, we need to create opportunities for everyone to participate and have the opportunity to change mindsets and behavior. And also last year, with our first virtual festival, it created, of course, a lot more opportunities for a broader audience globally to participate. But I must say, the challenge for us was, as a physical event, we went through a lot of effort to make it accessible, also for people from poorer communities. And when it comes to connectivity and having access online, of course, there again, you completely cut off a big part of that population that we used to host. And then just to see the difficulties between people who are in severe poverty, there's a choice between the money they have for education or for food. What do you choose? What do you, so I think you understand the point I'm making. It's difficult to see parents choosing the little bit of money they have between using it for food and using it to access online education.
Thank you very much. Brady, what was your experience? What is your experience?
Hey guys. Well, so I think this, I'm going to answer this in a couple different ways. So like in terms of smart geometry, when COVID hit and the pandemic hit, it obviously impacted our events. And I think it had probably impacted them more than you would imagine, right? Because this is about technology, and the entire community is very tech savvy, you could say. But I think the Smart Geometry event is really centered around meeting each other in physical space and talking and communicating and working together in such an intense fashion that working virtually wasn't an option. So we decided to take a bit of a hiatus on the actual event and come back. So we just chose to take a pause on it. But obviously I teach computation and design in other contexts as well. And I did find like one of the sort of liberating aspects, I guess, of working virtually is this sort of that distances disappear and we can get collaborators in from all around the world. And so in my classes, I would regularly have international people come in and give little talks, and which was wonderful to sort of have this connection that we never had before, that we could sort of connect. And that was sort of, our hand was forced to do this in a way by COVID. But I would say that one of the big takeaways really has been a realization for myself how much doing computation and design really does require sort of a very much an in-person approach, and this has been a real challenge for teaching computation, particularly to younger students and students who are just getting into this for the first time.
Zsolt, I know that you spent a significant time even in another country, locked out from your campus, and also teared off from this wonderful student team you have. So how you survived this period?
So I think for us, it was a really good opportunity because we are working a lot with technology, but it was more like a toy in education. And then when the pandemic hit, then it became a serious issue. So from the perspective of GeoGebra, then it started to be taken seriously. Before that, we have been doing lots of very interesting things and then lots of creativities, but it was more like the kids playing in the kindergarten, that we are doing really cool things. But afterwards, it was taken really seriously in education, because every school had to go online, and then it really made a really creative impact. And then there are lots of creativities emerged from the use of technology, and then the projects we have been doing just picked up everywhere, and then it was a really interesting environment. At the same time, from the doctoral school point of view, we always had for 5 years now these hybrid classes. So half of the students were here, half of the students everywhere. So it was not a big change for us, but now it's even a more substantial opportunity for us to make this network stronger and then work together. So we always had speakers from all over the world. We organized these events, and now it's even more strong, and then we can reach more people. So I think the drawback could be that when after the pandemic, the policies and everything go back to kind of normal, and then all of the creativity and then the new approaches in education try to be forced back to the same kind of stick to the curriculum and then so on. So I think what we need to do is just continue this legacy of opportunities. Of course, in spite of the difficulties, but I think then there is a good opportunity for us to push forward in this creativity and then the development of technology and innovation. So,
thank you. There were many connections between these really in-depth thoughts what you presented. If I want to find those common points, it really came down to me like that design is really a mindset. So it's a way of looking at the world. When we talk about the design as an activity, or design pedagogy, or learning about design, and also design thinking in education. And we know that this mindset is not supported or not given enough space and opportunities equally all around the world. What would you suggest to the teachers from your own specific viewpoints, what they can do for this mindset, for the growth of this mindset around the world, what you just presented? So everyday message from design thinking and design education, and also design thinking in educational research context.
If I look at, if I just think about the point I made about nature and biomimicry, and we look at how we're still teaching, for instance, something like life sciences, biology today, I think just by bringing in biomimicry examples, you're already connecting so many different subjects by doing that. You're bringing in the science and the maths and the technology, and you're making it relevant to kind of the man-made world that we are designing. And I think it could be quite an interesting place to start. So I think a lot of teachers are scared to try new things. A lot of them have been teaching in the same way for so long that they feel maybe scared or incompetent to try something new, although they are always, you know, the educators that wants to experiment. So that's one of the things I think to start in more, because I know if I'm going to say everybody needs to offer art, then, you know, most people are going to say no. But I think a good place to start is with a traditional, can I say, academic place like biology, life sciences, and to introduce biomimicry, because it's going to bring in the opportunities to play and to experiment and to build models. And with that, I think organically and naturally, there's going to become conversations between educators from different subjects, and it will just happen organically. And I think teachers must kind of try to be more playful when they educate. You know, the learning environment is not conducive for participation. Challenge yourself, maybe ask the learners to come up with a playful experience to teach something, you know, give them the opportunity to come up with a playful experience. I'm sure my Brady and Zsolt has got a lot more to add, so I'm going to end there.
Thank you, Suné. Before Brady, you would start to answer my question, let me complete it with a question coming in from Brian Sheldon. I think it very much belongs to here. So Brian asks, what can a school learn from your experience organizing smart geometry? Education is supposed to be a place where cross-curricular collaboration yields knowledge development. How do we encourage or make that happen in the often closed environment of schools or education?
Right. So, yeah, I think one of the interesting things with smart geometry is that we never had any, in starting the group, we never really had intention of educating. You know, we were interested in learning. That's what we wanted to do. You know, smart geometry was born out of practice. And we wanted to find somewhere where we could go and we could learn. And so we had to create the environment, this learning environment, where we could bring people in and create the right mix of event and talks and things to do in which we could learn. And maybe that's could be a strategy, a way forward, to think of yourself as a learner instead of an educator. And, you know, so how can we create these environments that really, where we can learn what we want to learn about the world. And I think that this act of doing was so critical. And maybe that's because we came from practice instead of from research, that we just really wanted to immediately go in and get our hands dirty and experiment with this stuff. But maybe that's what I would say. Flip the question.
Yeah, thank you, Zsolt. You also work a lot together with teachers who are really in the field, and in these critical times we might say that they are really in the front line. So what's your best advice for them? How do you encourage them?
So I think it's really the community, and I think many times the problem is that teachers don't believe that it's possible to do creativity and doing lots of things. But if you look around, there is incredible creative and innovative ways to use teaching, and it's all available on the internet. And then find the right people and then work together, share the experiences. So then there is already amazing work which is there, and then also doing these kind of conferences, and then also just creating some smaller groups to share experiences, and then find open educational resources and good practices. Then there is already a lot of there, try it and then share the improvement. So that is then the kind of continuous design that whatever is there. So then that's what we experience with GeoGebra. So every day there are 5,000 to 10,000 new resources emerge on the GeoGebra materials platform. So there is so many things around. And what we need to do is just get encouragement from each other. And then I think it will really, so yesterday we were talking about that whole policies and the curriculum will change. It will change if we do it. Because after a while, if we do so innovative and creative ways to teach, I think the current system will look so ridiculous that it has to change, because it would be embarrassing for the system to remain as it is. So I think then that's what we need to do, just do what we like to do.
So in Suné style, I might dare to say that don't wait for the change, be the change, right? Something like that. And this is actually true, and we know it also from practice. And our time is over, though many positive reactions came from the people who are here today. And I also think that we would need more of these kind of conversations, and because these also make the technical conversations meaningful, and also the methodology conversations get into a broad cultural context, and we don't miss the complexity of these important questions in pedagogy, what this conference also discussing. So I would like to say thank you for all the participants of this session. Thank you for sharing your presentations. And before I would say goodbye, I would like to challenge you, because Irina Yubinskaya from Columbia University had a very exciting question, which is too complex, too broad to be answered in one sentence, but I would like to ask you to do so. So the question goes like that. Do you believe education can go back to pre-pandemic normal in terms of technology use in the classrooms, or did pandemic irreversibly change the way we look at technology? How do you envision use of technology in post-pandemic classrooms? So very briefly, please, who takes the first place?
So maybe I take the first place. So I think it's not possible to go back, although I think politicians or policymakers want things to be back, because then that is the easier way, as it was, that teach, take the exams. But I think then there is something started, and I think it's very difficult to reverse now.
I think there's a saying about toothpaste in a tube or something, right? So now that we've sort of started working differently, I think that there can't be a return to in some ways. But that being said, there's a lot of inertia. People are used to doing things in certain ways, and we see this with technology all the time. That we sort of when confronted with a new technology, we reimagine it the way we did before. Right. So, so the way that we're using technology right now is just a reimagination of that classroom. And we need to really think of this actually in a totally new way. And I think the pandemic has perhaps started that conversation, but there's still more innovation to come.
I think it's going to be quite interesting to see the underlying skills that the learners develop because of this whole virtual experience. And I think they learned a sense of independency. And it's going to be interesting, when everyone's back in the classroom again, hopefully not the same type of classroom by then. I think the learners have been empowered with a sense of that independence. And I think they're going to determine how they want their education to be. I think because everyone suddenly learned new skills, the skills that they didn't learn, they certainly learned a lot more skills than they had before all of this happened. And I think they're going to become, I think that's human nature. They're going to become playful and experimental with these new skills and tools, and hopefully demand a different way of more kind of a collective approach in terms of how they want to be educated, you know. Let's see what happens.
Thank you very much, Suné, Brady, and Zsolt, for your contribution. Thank you for everyone who dare to make questions and comments in the chat. I think this is just the start of this conversation, and I'm sure that Zsolt will give us the space and opportunity to scale up also our conversation and involve the teachers and the students and the children and parents also in this dialogue. So thank you for starting, also helping to think about these questions together with you. Thank you.
Thank you for having me.
Thank you. Thank you.
And thank you, Kristof, for leading the session. And we have been already discussing with Kristof that we are trying to start a movement, and then it would be really good that if you are joining. So I think more details are coming soon. So we will have many of these kind of events, but I think we are planning something more to connect design and all arts to education. So I think it will be lots of opportunities in the future. So thank you again. And it looks that we used the time for the break, but I'm sure it was a very exciting session. So maybe we can use some time later, because we need to keep the schedule. So we have a quite tight schedule, especially because of the time differences. So thank you again, Brady, to wake up so early. So thank you for everyone. So we will collect all the presentations, and everything will be shared on the website, and then there will be continuation for this. And we will start the parallel sessions in 1 minute. So I will create 4 rooms. So the schedule is already on the website, or maybe Martin, you could share the link with the schedule, so you can decide which session you will go. And also, please use your full name and then add your country or institution for the names, because it will be very useful for the participants. Yeah. So the sessions will be 5, 6, 7, or 8. Imam just reminded me, but we will have 4 rooms. So session 5 will be room 1, session 6 will be room 2, and then so on. So it's like by columns. And also in the smaller rooms, it would be nice for the presenters that if you can turn on your cameras, at least in the beginning. So the session chairs will explain everything, and then please record the sessions, and then we will post them on YouTube. So Eva and Martin, is there anything then that I need to mention before starting the rooms?
I think I should change my